In this video, we're going to talk about different properties of exponents. We're also going to talk about rewriting radicals in exponent form and exponentials in radical form, as well as simplifying. So, a couple of things to think about. So, just remember some of our basic rules, right? If we have just anything like 2 to the third times 2 to the fourth times 2 to the, -2. Okay, remember the property here is that when we're multiplying the same base, we're going to add the exponents. So here I'd have 2 to the 3 plus 4 plus -2. And then you simplify that exponent. So you'd have 2 to the, this would be 7 plus -2, which would be to the 5th power. And you could write that as a single whole number, which is 32. This and this would both be acceptable forms there. Other key properties to remember are a power to a power. So if we have something like 3 to the 4th to the 6th, right, you multiply those two exponents, which would be 3 to the 24th, which is going to be a big number, so we're just going to leave it like this for right now. Again, you could use your calculator to write that as a whole number, but I'm not asking you to do that at this moment. Now let's talk about rewriting. Let's talk about those rational exponents. So that's when we have something with like a base of 3 to, let's say, the 4/3 power, okay? This is equivalent to the third root, the cube root of 3 to the 4th power. So we can leave it like this. We could rewrite it as the cube root of 3 to the 4th power as well. Oh, excuse me. We could also write it as the cube root of 81 because 3 to the 4th power is 81. If we try to find the cube root of 81, we actually get an irrational number. We get a decimal, so we're going to leave it like this. This is going to be our final answer here. We could also do the reverse, right? If I give you a radical, so if I give you something like, the 4th root of 8 squared, that's the same thing as 8 to the 2 over 4, right? And then we could reduce that if we needed to. 2 over 4 is 1/2, so this is really an equivalent of the square root of 8. But again, we wanted to write this without a radical, so we would not want to write it like that. We would leave it as this. We were rewriting it with rational exponents. I also wanted to take this opportunity to talk about negative exponents. So remember, whenever we have that negative exponent, it's going to turn our value into a fraction. So even if we just have, like, say, x to the -2, anytime we have that, that's going to become 1 over the base and then whatever that exponent is, so 1 over x squared. If we have a number here, so if we had, a base of 4 to the -2, that would be 1 over 4 squared, so that would be the same as 1 over 16. That stays true even if we have a fraction as our exponent. So if I have 4 to the -2/3, that exponent still drops down into our denominator, so 4 to the 2/3 over, 1 over 4 to the 2/3. And then we could rewrite that as in our radical form, right? That would be the cube root of 4 squared. If we wanted to simplify it again, remember 4 squared is 16. But this would also be an acceptable answer. So remember, that negative doesn't make our base negative. That negative really turns our value into a fraction with our base and our exponent being in the denominator.